So I'm going to show you guys where this is, especially if you didn't have me last semester, because you might not be familiar with how I set the Canvas pages up on these things. So on my Canvas page, here's our today page. Come on. You want to complete the review. I don't know why we don't have a task 2 on there. Obviously, I need to change that. Down here, I've got the answers in green, and then all the way at the bottom, there's my worked out solutions. That includes the stuff in the book in addition to the stuff that's on the worksheet. And if you did not look at the pages in the book for that suggested review, I would highly encourage you to get it out and look at it, because there are things that are in the book that we studied that are not on this review here. It's not like I duplicated all the questions. If the book had a good question, I didn't bother reinventing the wheel. I said, go do this problem number. If the book didn't have a good example for that type of problem, that's what I put on this worksheet. Okay? So if you did not get in and look at the stuff in the book, please make sure that you get in and look at the stuff in the book. Is there anything in particular, either off the review or just in general, that you want to see or talk about? Yes. 6.7? Absolutely. The application stuff?
Yeah, 8, 9, and 10.
Okay. Give me just a moment, and I will get that up for us.
It's a bit like, how many of those type questions? I'm gonna like one. I don't know. I feel like it has like 3,000 steps.
Let me erase this.
I just have to take it out.
Sorry, I should have had this ready to roll, and I don't know. Well, no, I know why. It's because my board is being difficult. Okay. Let's find some good ones. So like where it says triangle trig application, so like here we're starting with question 8. Okay. So question 8 says an archer is standing on top of a platform that is 6 meters high and is aiming at a target they have sighted 30 meters away. I'm going to stop right there and begin drawing a picture. And you guys already know to laugh at my horrible pictures. Do they tell us how tall the archer is? No, they tell us how high up in the air the archer is, right? He's on this stand that's 6 feet, but we don't know how tall he is. So we're going to assume that he's just like right at 6 feet. So I've got this platform that he's on. And here's my little archer. Isn't his bow awesome? Right? Here's his arrow. Yay. Okay, so he's 6 feet up in the air here.
Isn't it 6 meters?
6 meters, yes. Thank you for correcting me on that. He's 6 meters up in the air. He's shooting at a target. Roughly speaking, where is the target located? So is that 30 meters like this? Or is that 30 meters like this? Like that. It says he sighted it. So he's looking, and it's 30 meters along his line of sight, which he's tipped his view to be able to see that. So we have 30 meters. And he's going for the bullseye. The archer aims at an angle of depression of 10 degrees, 30 seconds. Where's the angle of depression in my picture? What'd you say? Down by the target? That sort of, but remember, I'm the archer, so we have to do this from the archer's perspective. What did you say, Tommy? Yeah, it's going to be outside of kind of this triangle that I've drawn. It's the difference between if our archer were to look straight and then how much he has to rotate his head down to see the target. You are correct that that is the same angle because of alternate interior angles as being down by our target. But I always want to try to keep in mind, especially because I know with these application problems, if you start changing your location, it gets very confusing. So just making sure that you're staying present with whoever the person in the story is, or like on the boat story problems, like you're always on the boat. And so you want to keep yourself in that frame of reference. 10 degrees, 30 seconds. What would that be in just decimal degrees? 10.5, because there's how many minutes in a degree? 60. So if it's 30 seconds, that's going to be exactly half a degree. And I'm going to change it into 10.5 degrees because we're going to be using one of our trig functions here, and I can't put in minutes and seconds there. What is it that I'm wanting to know in the problem? How far off the ground the bullseye is. The bullseye is like in the center of the target, right? So even if the target itself was on the ground, is the bullseye going to be on the ground? No. The bullseye is going to be somewhere up off the ground because we have this round target and then the bullseye is in the center. We want to know, what is this distance right here? Will that be my final answer, though? No. The final answer that I'm looking for is this. How far is it off the ground? Bullseye to ground. I know that whole distance, what I did right here in green, together with what I did in blue, that full distance is how much?
6.
That's 6 feet, or 6 meters. So from here to here is 6 meters. Sine, why sine? Yes, we want to find the opposite. So I'm going to do sine of 10.5 degrees equals what? I'm going to call this x right here. X over 30. And then I can find x by doing what? Multiply both sides by 30. And so we get that x is approximately how much? 5.467 meters, right? So how far off the ground is the bullseye? Subtract that from 6, yes. So we're going to do 6. Very good, yes. 0.533, right? I was going to say, I'm doing this in my head. Okay. Before we look at anything else, what questions do you guys have about this one? Yes, ma'am.
Would that be definite or approximate for the final?
Technically, it would be approximate, because we did have to round that.
Miss Bo,
Yes.
It's okay, you just tangent.
Where did I put my answer key?
Yeah, you will. I think you just wrote it down wrong, but I was thinking you were looking at it.
It's quite possible that I did write it down wrong. I have it correct on here and incorrect on there. Thank you. I'll get that fixed. Okay.
Yeah, I was
I have
looking
a
at
question.
Yeah.
I was like, why did she use Karen Jill? I was like, I'm sure she's right. But
Yeah. No. It should have been signed, and that's what I had on my, like when I worked it out by hand on paper.
Okay, so I have a question.
Mm-hmm.
So for the test, will we be able to have like a blank unit circle that I can fill out for the test?
You'll need to draw your own.
That's.
could you like print out
Get
a
a
blank
blank
one?
piece of paper?
I can give you a blank piece of paper.
Okay.
Absolutely.
Can't print out a blank one this next week.
No.
Can you give us one? Yeah.
No.
Why not?
If you want your unit circle, you can draw it.
This one looks so bad.
I'm not saying I just worry about drawing a circle. I got you.
But yeah, I'm happy to give you like just a blank piece of paper and you can sketch it out.
You
Yes.
can have a circle and
Did you guys want to go over any of the other application problems?
all of them. But
All of them, okay.
Also number 7. 'cause-
Also number 7, okay. Well, let's do 9 and 10 and then we'll go back and do 7. A cannon is fired at sea level and the cannonball climbs at a constant angle of 30 degrees through a distance of 500 feet. All right, so here's my really bad cannon. And it fires this cannonball. What's the angle that they gave us? 30 degrees. I like that. Why do I like that 30-degree angle? 30, 60, 90 triangle. I don't even have to break out my calculator for 30, 60, 90 triangles. How long did it keep this up? How far did it go? 500 feet. And then we're assuming that it hit its target or they stopped tracking it or what have you. We want to know, once it hit that 500-foot mark, it had traveled 500 feet, how high was it? You guys should be able to answer this one right here with just this information and without a calculator. What did we say? Not 5. I don't even need my sine, cosine, tangent.
It's like a square root of 30 something.
250. Why is it 250?
Because it's half of the hypotenuse.
Yes. On a 30, 60, 90 triangle, you have x, your hypotenuse is 2x. This distance down here is x square root of 3. So if we know our hypotenuse is 500 feet, then that height, the short side, would be 250 feet.
Wait, so why is the 30-degree side 2 times the 90-degree side? Wouldn't it be like, since 60 degrees is double 30 degrees, wouldn't that be?
Seems to make sense like that, but that's not, it doesn't work that way necessarily between the angles and the sides. Yeah, it just doesn't, logically, that seems to make sense, but that's not the way it works. Okay, so our height is 250 feet. So what would the horizontal distance be then? Yes, 250 square root of 3 feet. If they wanted a decimal or an approximate, then we could take 250 square root of 3 and pop it in a calculator. But if we didn't have access to a calculator, we could still get to 250 square root of 3. So our horizontal distance is 250 radical 3 feet. Number 10, and then I'm thinking that there aren't any other application problems on the review, are there? It's just those. What'd you say, dear? It's a 30, 60, 90 triangle. So it has these relationships right here. Your hypotenuse is always going to be twice your short side. Well, here's my hypotenuse. My short side is going to be half of that because the hypotenuse is always twice the short side. The long side is always going to be the short side times radical 3. So once I know that the short side of this triangle is 250, this side has to be 250 radical 3. Because that's true on all your 30, 60, 90s. If you don't know your 30, 60, 90 and your 45, 45, 90 relationships, if you can't draw this right here from memory for a 30, 60, 90, that's definitely something you want to work on tonight. What is the relationship on a 45, 45, 90? Yep, the legs are the same, so x, x, and the hypotenuse is x radical 2. X, x, x radical 2 for a 45, 45, 90. For a 30, 60, 90, short is x, hypotenuse is 2x. Long leg is x root 3. Yeah. So like this one right here, that one's already drawn for us. Your 45, 45, 90, and you're welcome to orient it however you want on the page. I'll tell you right now that one of the things that they do on standardized tests to take questions from easy to hard is they take the same thing that you're familiar with and they just turn it. So taking a 45, 45, 90 triangle and drawing it like that bumps up the difficulty level, even though the question didn't get any harder. On a 45, 45, 90, you have x, x, and x square root of 2. Tomorrow, by the way, is the no calculator portion. Wednesday is the calculator portion. I think I had misrepresented that the other day, and I'm sorry. Tomorrow's the no calculator. Wednesday is the calculator. Yes, Tom.
What if you don't want to live in radical?
Then you would put it into your calculator. But if a question like this falls on the no calculator portion, then you would need to leave it with the radical. Yes, ma'am.
Which types of problems can we not use a calculator for?
Unit circle questions, or anything that was similar to like unit circle quiz. So even though I might be asking about tangent or cosecant, if it's one of the ones that comes right off of that unit circle, you cannot use the calculators on those. Converting between radians and degrees. So you would need to know how to do that conversion and, if necessary, reduce any fractions without a calculator. Let me try to think. Graphing, but you don't really use a calculator for the graphing problems. Writing 6 trig values for anything where I either give you some of the sides and you just use Pythagorean theorem to find the other one, or if it's a unit circle value.
So
Those would be the types of things.
That's what's going to be on the test score.
Yeah, those types of things.
Wait, so are we going to finish the unit circle before we start?
You're welcome to draw one on your own, but I'm not going to give you one.
That stinks.
I will give you a blank piece of paper if you'd rather draw it on a blank piece of paper.
Why can't you give us like a little thing with you?
Like, yeah, can you
No, but like,
the thing to make a circle though, because like, the circle's gonna look really bad.
But it's only for your own reference.
Yeah, but like I'm gonna mess it up.
It's only for your own reference. All right. The biggest reason why there definitely is a calculator portion instead of it just all being no calculator is anything where I ask you to find, like here, sine of 10.5 degrees. You guys can't do that without a calculator. Or on questions like 10, where I'm asking for a bearing, I'm asking for an angle, so you're going to have to use an inverse trig function to do that. You can't do that without a calculator.
Oh, so you guys split up the test?
Yeah.
And you can't see?
Because there's definitely things where I just want to know if you know it. Like unit circle stuff, definitely no calculator. You need to have those pieces memorized. You need to know how to use those. For questions like these, though, you can't get past the setup of the problem without a calculator. Let's go ahead and do 10, and then I know you said you wanted to do 7, and then I'm happy to do anything else you guys want to look at. An airplane is 45 miles south and 16 miles west of the Indianapolis airport. So I'm going to draw my airport on here. And the airplane is southwest of there.
Oh, okay. Yeah, I was visualizing that wrong.
The plane is going to fly to the airport. And they gave us how far south and how far west, right? How far south are we? 45 miles. And how far west? 16 miles. We want to know the bearing that the plane needs to fly on. Where should I put my compass rose? Where the plane is, not where the airport is. The airport is not the thing moving. The plane is the thing that's moving. It's going to travel, so it needs to have the north, south, east, west here. North, south, east, and west. I already know 2 important directional pieces of the bearing. Directionally, this plane is going to have to fly which way? North and east. So we have north, something, east. What angle do I need?
Since it's gonna be
That one there?
It's gonna be on the outside, but it's gonna reflect.
Yes. We want this angle right here that's on the outside of the triangle. And I like that you corrected. You're right. It is going to end up being congruent to that one. But we always want to orient ourselves, because later when we get into problems like here we are and then we're going to head on a different bearing, like I want to make sure that we are always staying with the thing that's moving.
Why do we want the outside of the track?
Because the bearing is always going to be the angle that it makes with the y-axis, the north-south axis. So here's my bearing angle. I'm going to find this angle down here, that inside the triangle angle, so the other one that's down by the airplane. You could switch it around. But I'm going to find this one down here. And then what would I still need to do to get my bearing if I find this one right here? Yes. So my bearing is going to be equal to 90 degrees minus the angle that's inside the triangle by the airplane. I promise there's a reason that I'm doing this. You found a congruent angle that would work fine, but I like to keep myself focused on the plane and only finding the angles that are around there. How do I find this angle alpha right here? Tangent. So we're going to do inverse tangent of what? 45 over 16. So alpha would be what then? Yep. 70 point. I'm going to take it out to 3 decimal places because they do ask us to change it into degrees, minutes, seconds. So anytime we're doing degrees, minutes, seconds, you want to take it out to at least 3 decimal places to make sure that you are as precise as possible.
How do you get the tangent on that one?
Inverse tangent is how you find an angle. So we do tangent of alpha equals 45/16. To undo the tangent function, you need inverse tangent. So whenever you're looking for an angle, you have to use the inverse function. So what is my bearing angle then? 19.973? Or 573, sorry. 573. So when I go to write this bearing, I know the north and the east part already. I know the 19 degrees. How do I do the minutes and the seconds part now? 0.573 times 60. That'll give me my minutes. You said 34.38? So this is 34 minutes. And then we're going to do that 0.38 minutes times 60 seconds. And we get what? 23. Didn't it come out to like 22.8? 22.8 seconds, so round to 23. So there's my bearing. Questions like this, yes, you will be allowed to use a calculator. You can't find an angle without a calculator unless it's a 30, 60, 90 or a 45, 45, 90. And while you should be able to do degrees, minutes, seconds without a calculator, it's a lot faster with a calculator. All right, Maya, you wanted to look at number 7 yet. Oh, yes. So many words here.
Go back for a minute.
Yep. You know this is all posted on Canvas already, right? Although I will post the video from today because a lot of times the conversation helps.
Yep, it does.
If the conversation didn't help, then y'all would have no reason to show up in my class. Okay. What's going on in this problem? These angles are doing what? Trisecting. What does that mean? What'd you say? I just still can't hear you. I'm sorry. Yes, it's going to cut it into 3 equal parts. Yes, sorry. I just couldn't hear you. If they said bisect instead of trisect, what would it mean? 2 equal parts. Trisect, we're going to cut into 3 equal parts. And we're looking in quad 2. So here's quad 2. I'm going to cut this into 3 equal parts. It says hint, angle gamma is going to be closer to the y-axis. So here's gamma. And angle phi is closer to the x-axis. So here's phi. I think I'm going to use a lighter blue for phi just so that I have something to keep them a little bit separated. So I want you to think about your unit circle. How many radians would this be?
2/3.
Yep, that's 2 pi over 3. So what about phi? What is this one? 5 pi over 6. So because we know the radian measure, because those are the things that trisect our quadrants are going to be the over 3s and the over 6s. That means we know our ordered pairs and we know our sine and cosine, right? There we go. So 2 pi over 3, what is that ordered pair? Negative 1/2 radical 3 over 2. So let's do the 6 for gamma. So what is my sine of gamma? Radical 3 over 2. What is my cosine for gamma? Negative 1/2. What is my tangent for gamma? Negative what? Negative radical 3. And then we can do cosecant for gamma. Two radical 3 over 3. Flip it over, rationalize your denominator. So what is our secant for gamma? Negative 2. And cotangent. Negative radical 3 over 3. This is a perfect example of the type of question where I would not give you a calculator. Even though up here I didn't say, give me the 6 trig values for 2 pi over 3, I gave you enough information to be able to figure out that we were talking about 2 pi over 3 and 5 pi over 6. What's my ordered pair for 5 pi over 6? Yes, negative radical 3 over 2 and 1/2. So let's do our 6 trigs for phi. Sine of phi is 1/2. Cosine of phi negative radical 3 over 2. What about tangent? Negative radical 3 over 3. Cosecant? 2. Secant? Negative 2 radical 3 over 3 is what I heard. And cotangent? Negative radical 3. Beautiful, beautiful. This is another reason why knowing your unit circle, taking the time to write it down at the beginning of the test would be really, really helpful. Again, I won't give you a blank one, but I will give you a blank piece of paper if that's what you want. You're welcome to jot it on any blank spot on your test that you might have. All right, we've got about 10 minutes left. What else do you guys want to talk about or look at?
I don't think that much. It was really just low. I need to practice again.
Number 15.
15.
I think there's only 14 questions.
Me too. Me too.
Yeah, there's only 14 questions. Oh, 13. I heard 15. I was like, I don't think that one's on there. All right, my amplitude. Amplitude's going to be 2. The negative just tells me that it's going to reflect. Period. 2 pi over 3. Domain. I need to wait until I graph it, right?
Yeah.
Because I need to know where those asymptotes are going to be. Same thing with my range. Are you looking for another copy of this, dear? I've got them right up here. You're right, they are normally in the back. Secant is the inverse of what? Yes. Inverse of cosine. So I'm going to do 3x plus pi over 2 equals 0 for my left endpoint.
Yes. We're just going over the review today. I'm just answering questions on the review, but I'll post the videos from it. If you're not feeling well, go home. Okay? If you're not feeling well, go home.
You're welcome. All right, so I'm going to have 3x equals negative pi over 2. Divide both sides by 3. My left endpoint falls where? Negative pi over 6. For my right endpoint, I have 3x plus pi over 2 equals 2 pi. So 3x equals 3 pi over 2, right? Because it would be 2 pi is the same thing as 4 pi over 2 minus 1 pi over 2. So I get 3 pi over 2. Divide both sides by 3. 3 pi over 6, which is pi over 2. So I probably want to count by pi over 6's. So negative pi over 6, positive pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi, just to take it out a little bit further. We are inverse of cosine. What does cosine look like? Cosine looks like this, so inverse cosine looks like this. Cosine, inverse cosine. So my left and my right are going to go down. Do I have a shift that I need to worry about? Yes. We shifted down 2. So I'm using that as my midline. So at negative pi over 6, I need to go down 2 from the midline. At pi over 2, I need to go down 2 from the midline. What happens halfway in between these two? It's going to have the top part, right? It's maximum. Where's the maximum going to be? On the midline or above it? Above the midline. Halfway in between, we're going to go above the midline. 2 units. Halfway in between the maximum and the minimum is where we cross the midline at. So there's 1 period. Here's 2 periods. Where are my asymptotes going to fall? Anywhere cosine crosses the midline, not the x-axis. It's anywhere cosine crosses the midline. So it's happening here. It's happening here. It happens every how much? Every pi over 3. At every pi over 3, we have these asymptotes. So my domain would be all real numbers except x cannot equal pi over 3n. from the maximums, those parabolas point up. From the minimums, those parabolas point down. So my range, negative infinity to what? -4. Union, where does it pick up again? 0 to infinity. Awesome, awesome. I will tell you guys one more time, a plug to get into those book questions, especially the ones at the beginning. We haven't done a question like this in a while, but it showed up on the quiz. I'd pay attention to questions like that. That's number 4 in the book. Numbers 1 and 2 in the book are more conversion problems. Make sure that you can convert from radians to degrees and degrees to radians. Make sure you remember the formulas for arc length and area of a sector. All right. I will fix that one mistake that Maya found on the answer key. I'll make sure that that gets posted here within the next 5 minutes. If you guys find any other things that you think are errors or mistakes, please get in touch with me ASAP so that I can fix those.